In C# we'll be talking today about testing and test-driven development. Testing is where we write some code and test it. Test-driven development is when we do it round the other way. We actually write our tests first and then write our code. The concept of testing itself is really quite straightforward. Let's say that we had this function which is called divide, and we want to divide two integers. Then we want to be able to test it. Then we simply might write some code like this. Very straightforward. If it gives us the correct answer, then we print OK, else we'd print something else. So if I just run that, I'll just start that without debugging so that I don't need a console read line, and that should just produce our result of OK. So we've applied our own test. We might like to have a multiply function, an add function, etc. We might have many of these things. So let's try and get this on an organized basis. So for testing, what I'd like to do is to take this code here and remove and copy it. I'm going to cut it and put it into a library. So let me make a library. I'll make a new project and I'll choose a class library, and I'll call the project to be tested, and I'll call the solution testing solution. And I'll place my static function. Notice that I'm not talking about class methods here. We're talking about a static function, divide, that I want to test. I'm now going to add a project to test my library. So I'm going to, the best way I think is to right click on the solution here and add a new project, and I'm going to this time make it a test project. And I'm going to call it test code to be tested. The other one was called code to be tested. So I'm now going to click OK, and that should create my testing project, which is all part of the solution. So what I should do is set a reference to the from here, to set a reference and introduce its namespace, which I can do as follows. Let me just go back to the program to be tested and just pick up that name here, the namespace of that. So this is the one that's being tested. I'll just copy that. I'll go to my other unit test, and because I want to have a using statement here and I want to use that namespace, it's still complaining because I haven't set a reference, which I'll do now. To set a reference, I'll right click on here. Well, by the way, it looks as if I'm going to set that as the startup project. It goes bold, of course. It doesn't seem to be necessary, but I'll do that anyway. And now I want to add a reference, so I'm going to click add and then add a reference. This is just normal procedure for accessing a library. And there's my library, and so I can click OK. So you'll see now the red's disappeared, so the reference is properly set to my library. You'll notice that this using namespace has been introduced by Microsoft, and it allows us to use what we call an attribute. An attribute are just instructions. It could be to the assembly or could be to the compiler and so on. They're basically instructions to say that this is a test method. If you were to have, this is called a unit test, and so if I were to have another one of these, this would be another test method. One could be for testing for multiplication, addition, another one, and so on. So these are all individual unit tests. with the attribute, the overall attribute, that it's a test class. Now these methods are usually given a very meaningful name. It might seem a bit over the top here, but you'll see why it's important to be quite explicit about what this thing does. Now there are three things that we need to do here. The first one is that we need to set up our variables which are going to be tested, and so we've got a number which we're going to put in, two numbers we're going to put in to be divided, and you'd expect to get 2 from this procedure. The next stage is called an act. The first stage where we assign, it's a triple A. We've got assigning our variables. In this case we're acting. And finally we have the assign stage to see if they're equal. You'll notice that this assert has got quite a few methods here, a lot more than normal. So once we include this Microsoft using unit testing namespace, you'll find that you get a lot more assert methods. We can now build this. It's not actually necessary to build our solution. We could just run it, and that's succeeded. So to run our test, we go to the test menu. So you need to get used to that rather than going to just the run, and then we're going to run all tests. Since we've only got one, we might as well just run that. Now the output telling us whether it's passed or failed should appear here in the test explorer. So you can see that indeed our test has passed. We talk about a test failing, and that you would think, well, what it means is the code fails. So it's a bit misleading sometimes. We say the test fails. In fact, the code has done the failing. If you can't see your test explorer window, you can also get that through the test menu up here. You can go find that in Test Explorer. So let's see if we can make a failing test. Let's go back to our function, and let's say we make some sort of mistake in here. Then let's see if the test will work. So let's see, I'll just run my test. I can run all tests, and now let's see what result I get from Test Explorer. We should find that that gives us a failing test. So let me put that right. If I just return that to the proper divide sign, you could run that again if you wished. And you should find that your test has passed, of course, this time. So far we've been testing to see if we've getting a correct result. But what happens if we have an exception? For example, if we try and divide 6 by 0. In this case, we're trying to test for an exception, but we want to make sure that the correct exception is the one that's been thrown. In other words, we would expect a divide by 0 exception. So what we need to do is to make another method. And it's usually convenient to copy down, because usually it's much the same. So instead of 6 divided by 3, we're going to have 6 divided by 0. We're not going to expect any result here, and we're going to do the division, but we're going to expect an exception, a divide by 0 exception. So that's what we're doing here. We're testing if that particular exception is indeed returned. Now the attribute that we use in this case, you place this extra attribute in here. This is what we generally include when we're checking for a particular exception. But in this case, we're looking for a divide by 0 exception. Now, it's complaining here, obviously, because the name is the same. So once again, it's a good idea to put in some meaningful name. For example, divide by 0 exception. We're not asserting them to be the same. We just want to know if that's the exception, the correct exception that we're expecting. So now let's run our tests. We might as well just run all tests, and then in our test explorer we should have the results. We've got two tests which have been passed, one the divide by 0 and the other which we ignore for the moment, just concentrate on this one. The divide by 0 exception has indeed passed. Now what does it mean passed? It means we've got the exception that we expected. So for example, if we were expecting incorrectly a null reference exception, and then we were to run our test again, running all tests, or we could have just selected this test that we really want and just run that. I'll just run all tests, and you can see in this case that the exception test should fail because we're expecting the wrong exception. So let me just amend that and talk about single stepping. If we were to put a breakpoint somewhere in our code, then the way to single step that is to go through the test menu, but through the debug here. Debug all test, might as well for the moment, and that should therefore stop on that breakpoint. So when I run my tests through the debug menu, all test, it should stop on that breakpoint, and I could single step using F11, but if I just take a look at my value of C for the moment and then press F11, you can see that C has got the value of 2, for example. We've been discussing testing so far, where we've written the code and then tested it. But now let's talk about test-driven development when we do it around the other way. We write our test first without any code and then gradually build up the code. So I'm going to go into my and then pretend that we haven't even started developing at all, and we don't even have a divide function. And I go back to my unit test. I can just concentrate on. So you see I've written my test code, but I haven't got any implementation of it. So of course it's going to start complaining about the divide. So what I need to do is to go back and write a divide function. But take a look at this. Microsoft has very kindly showed us show potential fixes. So if I click in here, or if I press Control full stop, show potential fixes. So take a look at that. So when we right click on here, and well, we can just hold the mouse over here and see, and it says show potential fixes. Now this is actually quite magical actually. So if you watch in the right window, the instant I click this, it shows the changes. Now if I click on preview changes, watch what happens. Apply, and that appears in the second window. So it's made a program stub for us at the moment. So we don't need this in here, and we need to write our code to just get it working. Now this might surprise you, but to just get it working, we need to return, we're cheating really, we're going to return the expected value. So now if I run my test, we should find that the test has passed. Well, now let me try another set of values. Will this work? So if I run my test, you can pretty safely say that the test is not going to work because it's been set to give the value of 2 and we're expecting it to have 4. So obviously the test has failed. And it might sound a bit strange just to run it so that we're making it work with the minimum amount of coding. But this is the way we proceed, slowly. So therefore, let's try and amend our function and return a divide by b. Well, we need to, well, I'll amend that to make that a and that b. And now if I run my test, will it pass? Yes, it does. So you can see that we've successfully written our function. Well, that's illustrating how we use the Microsoft testing. There are other test frameworks, NUnit and XUnit, which require downloading from GitHub and so on, which I'll treat in another video.